Japan's flying car, problems and solutions. In the 1880s, the automobile represented the pinnacle of transportation innovation. 2 decades later, the Wright brothers revolutionized travel by achieving humanity's first successful flight. For over a century, people have speculated about merging these two groundbreaking technologies. The first serious attempt came in 1917 from aviator Glenn Curtiss, who developed the autoplane. This vehicle, powered by a rear-mounted 4-blade propeller, managed to lift off the ground but failed to achieve sustained flight. Another significant effort was the Aerocar, designed by inventor Moulton Taylor, which successfully flew in 1949. However, only 6 units were produced. Despite numerous attempts over the decades, no one has yet cracked the code of the flying car. Recently, a Japanese team revealed their latest endeavor in this quest. But will they succeed? In this video, we'll explore this attempt and delve into the broader electric aircraft market, examining both the challenges and potential solutions. Last month, Japan introduced a flying car created by SkyDrive, a company sponsored by Toyota. This vehicle, powered by 8 independent electric motors, has been under development since 2014 and was publicly demonstrated for the first time last month. Some might argue that this isn't a flying car, but rather a passenger drone. However, this is merely the testing phase. The next step involves adding wheels. A SkyDrive spokesperson explained, "Before developing a prototype with wheels, we would like to ensure that the incredibly difficult flight function has been achieved as a first step. We aim at driving function from late 2020. Essentially, they are focusing on the hardest part first, making the vehicle fly, before adding wheels, which is a relatively simple task." The spokesperson continued, "We believe that we can add more value in places like Japan and Asia, where the land is small and it is difficult to land and take off from." SkyDrive aims for commercial manned flights by 2023, with the final product costing around $1,000. They hope to reduce the cost by 2030. SkyDrive's unique selling point is its compact and lightweight design. Other companies, such as Airbus, Toyota, Porsche, and Boeing, are also developing similar technologies. In January, Hyundai and Uber announced their collaboration on an all-electric air taxi. After flying in one of the first all-electric aircraft, the Alpha Electro, I can see that small electric aircraft might become a reality. Morgan Stanley analysts predict that urban air taxis will be commonplace by 2040, with a global market valued at around $1.5 trillion. Why are electric aircraft gaining traction? They offer reduced emissions, lower running costs, and simpler maintenance. Electric aviation promises significant reductions in financial and environmental costs compared to traditional air transport. The Australian Airport Association notes that the biggest airline costs are fuel, 27%, and maintenance, 11%. Electric aircraft have lower running costs and are less complex than their fuel counterparts, thanks to fewer moving parts and simpler designs. They could also enhance the efficiency of local airports and enable airports to be located in more diverse areas. Many airports face curfews due to pollution regulations, causing congestion during operational hours. Electric aircraft could eliminate these restrictions, improving efficiency, reducing costs, and allowing for closer proximity to city centers. This opens up new work arrangement opportunities, although this has become less relevant with the rise of remote work. Despite these benefits, the emerging industry faces significant challenges. The primary challenge is ensuring sufficient battery energy density to support commercial flights. Advances in graphene, solid-state, and aluminum air batteries are promising and may be realized within a few years. By 2022, 9-seat planes could undertake short-haul flights of 500 to 1,000 kilometers. Israeli firm Aviation has developed a 9-passenger aircraft capable of flying up to 1,000 kilometers at an altitude of 3,000 meters and a speed of 440 kilometers per hour, expected to enter service in 2022. This aircraft uses aluminum air batteries, which have a specific energy of about 1,300 watt-hours per kilogram, compared to lithium-ion batteries 260 watt-hours per kilogram. Initial progress is likely in medium-sized fixed-wing aircraft. Smaller electric vertical takeoff and landing (eVTOL) aircraft might be less efficient. Ella Atkins, a professor of aerospace engineering at the University of Michigan, notes that eVTOL aircraft are going to be more energy efficient than helicopters that use a lot of fuel, but they will be less efficient than cars because they have to lift themselves. Therefore, they might not be practical for everyday tasks like grocery shopping. Even after solving the battery issue, another significant problem remains: charging standards. Consider the inconvenience if every car maker used a different fuel pump. This is the current state of electric vehicle charging standards. Manufacturers' chargers are not compatible, even within the same company across different regions. The Chidemo standard from Japan, originally developed by Nissan for the Leaf, has become redundant with newer standards. Tesla uses offers a proprietary standard in the United States with limited voltage capacity, another for Europe and Australia, and yet another for China and India. The newest Chinese standard, GBT, has surpassed all others in uptake and seems to be the future of fast charging. To avoid this mess in the future electric aircraft industry, aviation can learn from lessons learned in the electric car market and capitalize on the progress made with the Chinese standard. In 2018, Electro.Aero became the first to obtain regulatory approval to commercially operate an electric light sport aircraft for flight training. They identified the need for standardized aviation charging to accelerate electric aircraft adoption. Electro.Aero, the company I worked with while testing the Alpha Electro, faced challenges due to proprietary chargers and generators. Josh Portlock, CTO and co-founder of Electro.Aero, established an international committee in mid-2018 to develop electric aircraft charging standards. His team is close to finalizing a universal charging standard for aircraft, AS 6968, which has garnered support from electric aircraft companies worldwide. The company recently tested Australia's first microlight aircraft using this standard and offers a 30-kilowatt rapid charger that can recharge batteries in under an hour. The charger protocol is based on the Chinese standard, saving costs by not reinventing the wheel. The software protocol includes features specific to aviation, such as handling redundant batteries, common in aircraft but rare in electric cars. Future plans include automated cloud-based billing with aircraft identification, simplifying the charging process. While the current standard supports up to 250 kilowatts for 1 to 4-seater planes, megawatt power levels will eventually be needed. Addressing these issues brings us closer to an electric air taxi future. Flying cars failed in the past due to heavy, noisy power plants, a lack of lightweight electric motors, and the absence of carbon fiber structures. These vehicles compromised by trying to be both good cars and good aircraft. However, advancements in high power density batteries, low mass electric motors, low noise fans, and lightweight carbon composite structures have changed the landscape. Currently, 120 concept vehicles exist globally, increasing at a rate of 1 per week. Flying cars have long been a dream, with early attempts like Glenn Curtis's Autoplane and Moulton Taylor's Aerocar paving the way. Today, advancements in electric aviation bring us closer to realizing this vision. Companies like SkyDrive and Electro.Aero are leading the charge with innovative designs and standardized charging solutions. Despite challenges, such as battery energy density and charging standards, progress is promising. With continued innovation, the dream of flying cars may soon become a reality, revolutionizing transportation once again. The journey to create a flying car has been a long and challenging one, marked by numerous attempts and innovations over the past century. The latest endeavor from SkyDrive, supported by Toyota, represents a significant step forward in this quest. By focusing on achieving a stable and efficient flight function before adding the wheels, SkyDrive addresses one of the primary challenges that have plagued previous attempts. This phased approach ensures that the vehicle's most complex and critical aspect, its ability to fly, is perfected first. The compact and lightweight design of SkyDrive's model, powered by 8 independent electric motors, aims to offer a practical solution for congested urban environments, especially in regions like Japan and Asia where space is limited. If successful, this could mark a pivotal moment in urban mobility, offering a new dimension of travel that seamlessly integrates with existing infrastructure. However, the path to widespread adoption of flying cars is fraught with significant challenges. The primary technical hurdle lies in developing batteries with sufficient energy density to support sustained commercial flights. Advances in graphene, solid-state, and aluminum air batteries hold promise, but they are still in the development stages. Additionally, the issue of charging standards must be addressed to avoid the incompatibility problems seen in the electric car market. Standardized charging solutions, like those being developed by Electro.Aero, are crucial for the scalability and efficiency of electric aircraft. These solutions need to support the unique requirements of aviation, such as handling redundant batteries and enabling high-power rapid charging. Overcoming these challenges will require coordinated efforts across the industry, but the potential benefits, reduced emissions, lower operational costs, and improved urban mobility, make this an endeavor worth pursuing. If you enjoyed this content, be sure to subscribe. I'm curious about your thoughts on the electric aircraft industry. Do you believe we are just 5 years away from flying cars becoming a reality, or do you think it will take longer? Share your thoughts in the comments section below.